to generate massive, my cloud, this really big flock of sheep.
We might have run out of memory or computation power.
Yeah, so maybe we're actually pushing the limits of my Mac, my PCs, my cloud servers, memory, or CPU, the brains of the computer's capabilities, because it's just trying to generate massive lists of sheep, 1 million of those rows of sheep, each of which has a huge number of sheep. And it seems that my computer here is honestly just really struggling. And this is really unfortunate now, because it would seem that even though this program clearly works pretty well for 1,000 sheep, 10,000 sheep, once you cross some threshold, it just stops working altogether. Or it just takes way too long for the program to be useful anymore. But this seems a little silly, right? Because theoretically, I should absolutely be able to print all of these same sheep if I just printed 1 right away, then print 2 right away, then print 3, then 4, then 5. It seems that the essence of this problem, if I go back to my code, is that per my best practices, that I'm trying to practice what I'm preaching, it seems that the fundamental problem is that I've modularized my code by creating this helper function called sheep, whose purpose in life is to do all of the generation of sheep and then return all of them at once. Wouldn't it be better, and I can actually hear my fan turning on now even, just trying to generate these sheep, wouldn't it be better then to just print the sheep 1, 2, 3, 4 at a time? Well, we could do that, but that's really a step backwards. That rather contradicts all of the lessons learned of the past few weeks, where generally not putting everything in main is a good thing. Generally having an additional function that you can then test separately with unit tests is a good thing. Do we really need to give up all of those best practices just to print out some sheep and here fall asleep? Well, it turns out there's a solution to this problem, and namely in the form of these generators in Python. You can define a function as a generator whereby it can still generate a massive amount of data for your users, but you can have it return just a little bit of that data at a time. And you yourself can implement the code in almost the same way, but you don't have to worry about too much getting returned all at once. These two, like all features of Python, are documented in the official documentation therein. But what you'll find ultimately that it all boils down to this keyword here, yield. Up until now, when we've been making functions, we have been defining functions that return values, if at all, using the keyword return. And indeed, if we go back to our code here, that's exactly what I've been waiting for. I've been waiting to return the whole flock at once. Unfortunately, if you wait too long, and here we have it, my program was quote unquote killed. That is to say, my computer got so fed up with how much memory and CPU it was trying to use, it just said, nope, you're not going to run at all. And that's unfortunate. Now my program no longer works for large numbers of sheep, which is not good if I'm really having trouble falling asleep some night. So how can I use yield to solve this problem instead? Well, let me do this. Instead of building up this massive list of sheep in this big list called flock, let's just do this instead. Let me go ahead and simplify this whole function as follows, whereby I iterate for I in the range of n, and then on each iteration, in the past, I might have been inclined to use return and return something like 1 sheep times I, but this won't work here, right? Because if you want 1,000,000 sheep and you start a for loop saying for I in the range of 1,000,000, you're going to return accidentally 0 sheep right away. And then this function is essentially useless. You shouldn't return a value in the middle of a loop like this, because you're not going to get to any of these subsequent iterations of the loop. It's going to iterate once, and boom, you return. But thanks to this other keyword in Python called yield, you can tell Python to effectively return just 1 value at a time from this loop. So if I go back to this version of my code here, and I say not return, but yield, this is like saying return 1 value at a time. Return 1 value at a time. Return 1 value at a time. The for loop will keep working, and I will keep counting from 0 to 1 to 2, all the way up toward 1,000,000. But each time, the function is just going to hand you back a little piece of data. It's going to generate, so to speak, just a little bit of that data, not all of the data at once. And that's good, because my computer has a decent amount of RAM, certainly enough to fit 1 row of sheep. It just doesn't have enough memory to fit, apparently, 1,000,000 rows of so many sheep. So now, if I go to my terminal window and run Python of sleep.py and hit enter, what's n? 3 would still work, 0, then 1, and then 2. Let me go ahead and increase the size of this here and run Python of sleep.py. Let's try 1 million as before and hit enter. And now I immediately see results. I don't think we'll wait for all of these sheep to be printed, because then we will literally all be asleep. But what you'll notice happening now is the program is not hanging, so to speak. It's not waiting and waiting and thinking and trying to generate the entire flock at once. It's just generating one row of sheep at a time, and it's flickering on the screen because there's so many of them, and that's all thanks to yield. It's generating a little bit of data at a time, not all at once. Any questions now on this feature called generators? Any questions at all? To add one more piece of terminology to the mix, just so you've heard it, this same feature here is returning what we'll technically now call an iterator. Yield is returning an iterator that allows your own code, your own for loop in main, to iterate over these generated values one at a time.
How does this yield actually works under the hood? I mean, is it using multi-threading?
You can think of the implementation as being asynchronous in this sense, whereby the function is returning a value immediately and then subsequently giving you back another one as well. Underneath the hood, what's really happening is the generator is just retaining state for you. It is not going to run the entire loop from top to bottom and then return a value. It's going to do one iteration and yield a result, and the Python for you is going to suspend the function, if you will, but remember on what iteration it was. So the next time you iterate over it, as is going to happen again and again in this for loop in main, you get back another value again and again. So yield returns indeed this thing called an iterator, and that iterator can be stepped over as in a loop, one element at a time. But the language Python handles all of that for you so that you don't need to do all of the underlying plumbing yourself. How about time for one other question on these generators and iterators as our sheep continue to fly by?
So in every iteration, the program will return the memory to the system, so the program will not crash?
Correct. On each iteration, it's only returning the one string of sheep that's appropriate for the current value of I. It is not trying to return all million rows of the same, and therefore it uses really 1/1,000,000th the amount of memory, although that's a bit of an oversimplification. All right, as these sheep continue to fly across the screen, let me now go ahead and interrupt this, as you might have had to in the past with infinite loops in your own code. Even though this isn't infinite, it's just really long, Control-C will interrupt with your keyboard that program, giving me back control of my computer. Well, here we are at the end of CS50's introduction to programming with Python. And if today in particular of all days felt like a real escalation real quickly, realize that these are just additional, perhaps optional tools in your toolkit that you can add to all of the past lessons learned, so that as you exit from this course and tackle other courses or projects of your own, you have all the more of a mental model and all the more of a toolbox with which to solve those same problems. If we think back now just a few weeks ago, it was probably in our focus on functions and variables that you first started struggling. But now in retrospect, if you look back at those problems and those same problem sets, odds are those same problems would come all too easily to you now. Conditionals was the next step in the class, wherein we gave you the ability to ask questions and get answers and therefore do things conditionally in your code. We came full circle today, and you can see that you can now use those same kinds of conditionals now to do fancier things with list comprehensions and dictionary comprehensions and the like. Loops, of course, have been omnipresent now for weeks, including today as we built up those same structures. And of course, something can go wrong. And exceptions and exception handling was our mechanism for not only catching errors in code, but also raising your own exceptions, so that if you're laying the foundation to write code for other people, as in the form of libraries, you can do that too. Libraries, of course, are things you can not only use, but now write on your own, be it a small module or whole package of code that you want to share with others around the world. And even better, can you write tests? for your own code, for your libraries, for others' code as well, so that ultimately you can be all the more confident that not only your code is correct today, but if you make a change to your code tomorrow, you haven't broken anything, at least according to your tests, if they continue to pass. File I/O, though, meanwhile, was a way of now storing data not just in the computer's memory, like all of these sheep, but actually storing things persistently, longer term to disk, be it in a CSV or something more like a binary file like an image. With regular expressions, you then had the ability to express patterns and actually validate data or extract data from information, all the more of a useful technique nowadays when so much of the world is trying to analyze and process data at scale, some of which might in fact be quite messy from the get-go. And then, of course, most recently, object-oriented programming, an opportunity to solve the same kinds of problems but with a slightly different perspective, a way to encapsulate and to represent real-world entities, this time in code. And today, of course, etc., was so many other tools that you can add that didn't necessarily fall under any of those earlier umbrellas, but are useful functions and data types and techniques just to have, again, in your back pocket as yet other mechanisms for solving problems as well. Not just putting everyone to sleep, but I thought another way to end might be a little more vocally to try writing one final program together, this one using a library we've seen in the past, as well as one other. I've taken the liberty of installing a text-to-speech library on my computer here. And I'm going to go ahead perhaps and open a new file here called say.py in VS Code. And I'm going to go ahead here and first import our own friend, import cowsay. And I'm going to import this new library here, import pyttsx3, the Python text-to-speech library. And now, per its documentation, which I read in advance, I'm going to go ahead and create a variable for myself here, engine, equals pyttsx3.init to initialize that library for text-to-speech. I'm going to then ask the user, well, what do I want to hear spoken? And I might do something like this. A variable called this equals the return value of input. What's this shall be my simple question, and I'm going to keep it this time as a string. We've seen how to use cowsay. We can do cowsay.cow of this. Turns out this new library can allow me to use its own engine to say this as well. But then ultimately, I'm going to have to run the engine.run and wait, just in case it's a long phrase or sentence to be said. But that's it. In just 8 lines of code, not only am I apparently going to have a cow appear on the screen to close us out now, but also some synthesized text. Ultimately, then, we hope with this course that you've not only learned Python, that you've not only learned programming, but you've really learned how to solve problems and ultimately how to teach yourself new languages. Funny enough, I myself only learned Python just a few years ago. And even though I certainly went through some formal documentation and resources online, I mostly learned what I know now and even what I had to learn again for today by just asking lots of questions, be it of Google or friends who are more versed in this language than I. And so having that instinct, having that vocabulary by which to ask questions of others, to search for answers to questions, you absolutely now have enough of a foundation in Python and programming to go off and stand on your own. So you can certainly, and you're welcome and encouraged to go on and take other courses in Python and programming specifically, but better still, as quickly as you can, is to find some project that's personally of interest that uses Python or some other language, because at least from my own experience, I tend to learn best, and I hope you might too, by actually applying these skills, not to problems in the classroom, but really, truly, to problems in the real world. Allow me, with all that said, to look at my full screen terminal window here, run Python of say.py, crossing my fingers one final time in hopes that I've not made any mistakes or bugs. And here we go, Python of say.py prompting me, what's this? How about we end on this note here?
This was CS50.
This was CS50.